Hello, welcome back. Today we're going to be looking at derivatives but using data and finding derivatives from a table. It's pretty easy to do. We will be using the TI Inspire calculator on this lesson, so if you need one, go ahead and grab one. You can, I think there's also these, you can find them online, or you can even use Desmos calculator as well. So for the first example, they're telling us that water is flowing into a tank over a 24-hour period. The amount of water in the tank is modeled by a differentiable function. So there's that word differentiable again. That just means that the slope exists everywhere, that it's a smooth function, and that we can take a derivative. For t between 0 and 24, where t is measured in hours and w is measured in gallons. Values of w at selected times t are shown in the table below. This is a big question on the AP. You'll definitely see one of these. The first question says, use the data in the table to find W of 8. Well, that's easy to do. We're told that W of 8, and I can find that, is 221. Then it says, using appropriate units, explain the meaning of our answer. Well, this is just telling us that at 8 hours, there is exactly 221 gallons of water in the tank. So at 8 hours, now notice what I said, I'm using the time, at 8 hours, there's 221 gallons, and don't forget your units, of water. For part B, use the data in the table to find the inverse of 257. Remember, in math, this little symbol here says the inverse. So what that means for us is that this is no longer t, this is now our w. That is w right there. So we can say that the inverse at 257, so now I look at w, I find 257, and it's going to give me the time, 12 hours. And how could we explain this? Well, we can say I go in order, there are 257 gallons of water at 12 hours. And you can say gallons of water in the tank, gallons of water, we should probably say that, of water in the tank at 12 hours. Very simple. Now, if you say there are at 12 hours there's 257 gallons, that may be accepted, may not be. So that's kind of a gamble you take. The next one says, use the data in the table to find an approximation of W prime of 15. So this is where we start getting into calculus. I want to find the slope. We're looking for the slope here. So let's go ahead. To solve this one, though, we do have to get a little creative. Remember, this is a derivative, so I can't find the exact derivative because there's nothing here at 15, and even if there was, I'd be taking 15 and dividing it by 0, and that would be really weird. So, all right, so to do this, they tell us to approximate. So how do we approximate a derivative? Well, that is where our average rate of change comes into play. To find W prime of 15, I'm going to approximate it by looking at the values around it. Now, you might remember average rate of change. It's down here, f of b minus f of a over b minus a. Our average rate of change here, I'm going to pick numbers around 15. So I might pick 12 and 16, like so. So what I'm going to do is I'm going to find the W, the amount of gallons at 16, not 11, 16 minus the amount at 12. And I would divide that by 16 minus 12. I can simplify this. At 16, we're at 294 minus 257. And I would divide that by, of course, 4. So I'm going to use my calculator for this. There's my trusty Steve. I'm going to take this 294 minus 257. And that's going to give us 37 over 4. Unfortunately, it does not reduce. But let's talk about units. So they say use the units. Well, the top, remember, is my gallons. So the top, my unit is gallons. Bottom is my change in hours or time. So this is 37/4 gallons per hour. So what this says? Well, at t equals 15, the amount of water, we're going to write it this way, the amount of water. Now, let's talk about what it means to have a positive value. Remember, this is greater than 0, and this is a rate of change, which means this has a positive slope for us. So in terms of positive slope, we can say that this is increasing. So we can say at, t equals 15, the amount of water is increasing at a rate of 37/4 gallons per hour. And that's what we would say. Increasing because our same thing. So to get my average rate of change, hello nurse. To get the average rate of change, we want W of 20, where am I starting, where am I ending, minus W of 4 over 20. If this is A, that's going to be my B right there for my formula. And I can just go. I use my calculator again because I can't do simple arithmetic. 327 minus 184, and that's going to give me 143 over 16. So in terms of units, this would be, again, gallons per hour. And again, so quick question. Is the amount of water increasing or decreasing? Well, it's going to be increasing because this is positive, because our rate of change is positive. Very easy to do. All right, part E. Here it comes. Let's read it. Between 0 and 24, is there a time when the tank contains 256 gallons of water? Justify your answer. I don't know about you, but this sure does sound like IVT. So let's go up here real quick and to see if we cross 265 at least once. Oh yeah, look right here. Between 12 and 16, we go from 257 to 294. Well, you can go from 0 to 24 if you like too, because I'm starting at 150 and I go 357. So we definitely cross 265 somewhere in the middle there, at least once. So we're going to set this up. W of t is a continuous, don't forget to define its continuous function, it's continuous, there we go, function on the domain 0 to 24. You know, they're telling me 0 to 24, so I can. Next, step 1, right? Step 2, is the value at 0 not the same as the value at 24? Yeah, let's see here. 0 was 150, 24 was 357. So 150 does not equal 357. The third step is 256 between them. Is 265, excuse me, between them. And the answer, of course, is yes, yes, yes to all three. So therefore, remember, we're going to say, therefore, we can say IVT holds, and somewhere on that domain, 0 to 24, the value of the function, W of t, has to equal 265. So we know it has to equal 265. Oops, that's terrible to read. Let me rewrite that. There we go. Hard to read. And somewhere on the function, it has to equal 265. There's our answer. IVT, don't forget to mention IVT. We can easily verify too. If I'm starting at 0 to 24 and I'm going from 150 all the way to 357, at some point we have to cross 265 because this is a continuous function. There's no holes, gaps, jumps, or asymptotes. Now, how do we know it's continuous? Up here, they say differentiable. And differentiability, give me one second. And differentiability implies continuity. So we're good there. All right. So go ahead and go to video 2, and we can take a look at the next couple of examples. See you then.